Okay, we're gonna continue. So for here, we went through everything and we will talk about the task hierarchical organization. So the task item is the container for a set of related tasks. So the task consists of a set of steps to accomplish something. Step is a unit of work that we can see from here. We prepare Graffiti data for ArcGIS Online, task item, and task. So the task item we will do is prepare Graffiti data for ArcGIS Online, prepare data, share web layers. Enter data step. So that instructions enter a new date to replace the old date in the heading field in the heading attribute table, and then we will press enter to update the attribute field, close the attribute table, and create Graffiti feature class step. So the step is here. So task step automatically runs Graffiti data import model, which we will build here. And this is the model. So Graffiti data import model imports X and Y data into map layer, projects latitude and longitude to WGCS 1984 web indicator auxiliary sphere as feature class. Apply the unique symbols from layer file. Okay, and then we will share headings and Graffiti layer steps. So now we get started. So the first one, the book dealt with just the primary for, I'm gonna close everything out, yes. With a GIS applied to one-time projects, which spatial data is collected at one particular point in time and use ArcGIS Pro to help solve a problem. So now we'll shed light on an issue. So to solve a problem or share light on an issue. So for instance, that we did adjust the issue of geographic access to urgent healthcare clinics in parts of Pittsburgh with low-income populations, although the GIS could be updated with new data over time, so no organization or system was envisioned to continue the work. So in contrast with a one-time project, operations management applies to organizations that deliver goods and services. So operations signifies continuous work to provide goods and services to customers. So such work generates and depends on demand data for goods and services. So management refers to the oversight function for efficient, timely, and responsive delivery of demand services. An operations management system is an information system with supporting computer applications. A significant feature of such systems is that they process and use a continuous flow of demand data, in contrast with projects and one-time data collection. Because demand data is often spatial with point locations of demand, operation management systems often include GIS. So and here we're going to do is more we will build GIS-based operation management system for Graffiti, and we will build a Graffiti mapping system to help police identify patterns of serious graffiti artists, apprehend the artists, and prevent future graffiti. So apprehend the graffiti and prevent the future graffiti. The operation management system we will build here, so the graffiti removal system for the public works employees who remove graffiti from public surfaces such as buildings, walls, and bridges. The system performs optimal routing for graffiti removal at several locations during a work shift. So optimal routing determines the sequence of stops at graffiti sites to minimize travel time. So we will create task a model builder model in an operations dashboard operation view that police will use as their main tool to prevent graffiti. So first, we will be helpful for us to review the following information. So tasks are stored. Reusable workflow guides that load comments and manage map views and layers, thereby reducing mouse clicks and overhead. Task processing and output are consistent and reliable regardless of who does the work because of the repackaging and the instructional steps of tasks. So here we introduce model builder and models. A model automates a workflow consisting of two or more geoprocessing or analysis tools that become the process of the model. Each tool process is an algorithm that transforms inputs into outputs. Processes are strung together with the output, one process becoming the input of another process. Therefore, instead of searching for and running tools one after the other on your own, so we run a sequence of tools with one press of a button in a model. So you just click run. An operations dashboard for the dashboard for ArcGIS is an app for monitoring and reporting operations data over time. So I don't think I used that before, but that could be interesting to look into. So an operation views has one or more maps plus additional data displays such as statistics, charts, and queries. The system in here is one uses 311 data as input. Increasingly, citizens of American cities request to non-emergency public service using the phone number 311, which which is also the name for one-stop gateway department for providing such services. Besides calling 311, citizens can often use 311 website to record calls for services. The 311 system automatically sends service calls to responsive city departments such as police, public works, building inspection, and animal control to provide requested services. The reports of citizens asking for graffiti removal are a major kind of 311 data. So here we use 311 graffiti call data for Pittsburgh, but specific graffiti locations are random to protect data privacy. So, suppose that police determines that 12 weeks, 84 days of data is sufficient for identifying serious graffiti artists for raw data input to the graffiti mapping system. Assume that the Pittsburgh 311 system exports a CSV file with the most recent 84 days of graffiti data each time. We need to produce a weekly map. Included in the CSV data are the longitude and latitude of each graffiti location, such as Y and X and Y in the sample that here. Graffiti artists are known by their actual names, but rather by monikers such as Phrase 3 or Tommy T as seen in the artist attribute. Graffiti type code has code value tag, so throw up and piece, which are standard categories of graffiti. So tag is the simplest graffiti, which has the sign or moniker of a graffiti artist, generally with only one color. Throw up this quickly painted graffiti with some graphic features in addition to a tag and generally with a few colors. Piece is complex graffiti, a piece of art with several colors. So now we're going to create tasks for the graffiti mapping system. So a task item is the container that has a set of related tasks. So each task has one or more steps. So we will create a task item named Prepare Graffiti Data for ArcGIS Online for the weekly preparation of data from the graffiti mapping system. The task item has two tasks. So prepare data and publish web app layers and the following multiple steps in ArcGIS Pro. So the prepare data task has steps to enter a date in a feature class named heading and create a feature class named graffiti. So heading is a point feature class with a simple point. The point has a date attribute, also named heading, which stores the end date of the 84-day time window of graffiti data to be mapped. Every week, when we produce a new graffiti map, we must edit the state to be the current end date of the time window. So the dashboard we will build will display the state so that the user can learn the vintage of the map's data. The second step creates and symbolizes the Graffiti's feature class from the 84-day XY data table provided by the city's 311 system. So prepare data. The enter date step opens the heading attribute table and guides the user editing the heading date value. So the save edits help step saves the added date. The Great Graffiti feature class step runs a model builder model that we will build in this named Graffiti data import, which adds raw SCV data as an XY event layer to the ArcGIS project, creates the Graffiti feature class with projected web marketer coordinates from the XY data and symbolize the Graffiti layer using unique values by Graffiti type. So we will publish web layers, share web layers. Step publishes the heading and Graffiti web layer to the ArcGIS Online account. After the publish the web layer and they are added to an ArcGIS Online map, we can incorporate them into an operation view for analysis by police and other city officials who work on graffiti prevention. So the share heading web layer step publishes the heading web layer, and then share Graffiti web layer steps publishes the Graffiti web layer. So we will build the model for create Graffiti feature class step. Then we can create the task and steps for the task item for from start to finish with no interruptions. So now here we will still use the bookmark. So we go to Pittsburgh. So use this Pittsburgh bookmark. We will provide some background information here. So we will build a model builder model in here for creating and symbolize a Graffiti feature class from XY event data. The opening map already has a Graffiti feature class added because the model needs an existing Graffiti feature class for its symbolization process to function. Creating a new Graffiti feature class will replace the starting Graffiti feature class and symbolize it using unique values for different types of graffiti. The current Graffiti layer in the map is symbolized with a single symbol so that we can see that the model works the changes symbology to unique values. So we will build the Graffiti data import model. So when we build a model, we search for needed geoprocessing tools and then add them to the model. So at which time they are called process. So the model we will build here, same here, the first process is imports the raw XY data into a map layer. The second process projects the map layer from latitude, longitude, geographic coordinates to web marketer coordinates that are preferred for ArcGIS Online. The third process symbolizes Graffiti. Note that Graffiti, Graffiti 2, Graffiti 3 all refers to the same feature class. Graffiti model builder model inputs and outputs must have unique names in the model. Therefore, the 2 and 3 are created by model builder for Graffiti in different parts of the model. So on the analysis tab, the geoprocessing tab, so we can go to model builder. So then it opens a model builder. I don't like the docked window. That I'm gonna make it float and resize it and bring it back. And I don't think we need the animation timeline and everything. So I'm gonna close everything out, There. And now we have our model builder frame. And then on the analysis tab, in the geoprocessing group that we had, we clicked analysis here, we click model builder, and now we have a model builder tab. And we will click back to tools and we can search for tools and drag it here. So the first one we will add is make X and Y, make X and Y, XY event layer. Delete this, okay. And the second tool that we need, drag this tool here and similarly search for the project data management tool. So we have to do project. Alright, data management tool. Oh, I don't need to open the data. All right, and then I need another one is apply symbology from layer below the project tool. So apply symbology, apply symbology from layer. Okay, there. So then I'm gonna save my tool. All right, and then save it. Okay. All right, and then I'm gonna perfect, and we will continue talk about the model. All right, so now